I was working on May. That's where I was. We have Mailbag. We have some news in the wonderful world of open source hardware. We have Fritzing Friday. We got some Raspberry Pi news from the event that we attended. We've got some things from the Adafruit learning system. We've got a ton of new products. We've got some top secret products.
Ooh, secrets.
Oh, that's right. We're going to answer your questions. We're going to have a trivia question. We're going to have a cat. He's here. All that and more on Ask an Engineer. Okay.
We'll have to get through this stuff really fast.
We're going to go through a lot of stuff. So the code, everyone, is K-Town Griff. K-Town Griff gets about 10% off on many kits in the Adafruit store. Use the code K-Town Griff. Get 10% off kits.
That looks like something you would see spray painted on the sides of buildings here.
Yeah.
K-Town Griff. That's my
tag name. That's my tag name. Okay, we will do introduction in just a couple of minutes, but let's go straight to what just happened, which was the show. What just happened? The show and tell. Half an hour before the show, we do the show and tell, and there was lots of cool things. What did you see on the show and tell tonight?
On the show and tell, we started with Scott, the garlic Gufferson. I don't remember his last name. He was showing off his Bluetooth low energy 4 modules. He was working with the TI modules that were built by Blue Giga, showing off stuff he's building. He has some products he's making. It's all secret.
Kevin, you're working on some cool Bluetooth stuff soon, right?
Yeah.
Yeah, it was different chipset.
We're trying the Nordic chipset, but the TI chipset. The TI chipset's a little more powerful, but it's also kind of more of a pain in the ass to use. We also had Guillermo, who had a Raspberry Pi reset switch. He made his own little glowy reset switch, so you could actually turn on and off the Raspberry Pi without having to plug it in and unplug it and log in. So it's kind of an all-in-one kiosk button, which is really handy. Ray Wang came back a year later to show off the open sprinkler system, newer, better, wetter. He's got all sorts of demo boxes, web apps, iPads. It's crazy. Go to opensprinkler.org. I think, or .com.
You can also check the comments.
Try both. Whatever. Either way, you're going to find some open sprinklers.
There's probably only one open source
How many open sprinklers are there?
Actually, there's probably 12.
It's raining open sprinklers.
We had Lewis, who had a cool project. He took our LED backpacks that allow you to add LED matrices super easy, and he slapped through them into his IKEA $2 clock and added a Synapse Snap module, which runs Python, and it is going to alert him to all sorts of things.
Yeah. It was Adafruit time.
It's Adafruit time. We had Grant, who was building his reverse geocache puzzle. He used an ultimate GPS. It is so ultimate. And an LED matrix in one of our waterproof buttons. And he's going to give it to his girlfriend, and on her birthday she has to be in a specific place.
Yeah.
Or the world ends.
No.
That was pretty intense that he said how he was going to nuke the planet.
No, there was a box open.
Sorry, no, it just opens. The server goes off and it opens. Yeah. Okay. That'd be a good movie, though, right? In a world where you must get to the GPS location in time.
It'd be a good movie for people who like electronics.
It'd be a good reality TV series.
Yeah.
I'm surprised they haven't turned it into an ultimate chase sort of thing. Ethan is back for his high altitude project. Pretty much everyone is donating all this scientific equipment for him to put in this box, put into space. So a lot is riding on his shoulders and on his high altitude balloon.
Yeah.
He's got 5 GPSs and near what is it? The neutron detector bubbly thing. Some RF radios, some antennas, all sorts of crazy stuff. Yeah. So it's all going into near space.
Fantastic.
Let's go. Chris K now has a semi-autonomous speaking RiderNet. This is actually what's going to become the Terminator stuff. Everyone's always oh, don't make walking robots because they'll come and kill you. It's actually RiderScan. RiderScan is going to become, what was it, SynNet? Skynet. It's going to be RiderScan.
No, you know why it's not?
Because it's going to take over the horse brains, and the horse and the ponies are going to. No. They're going to have.
Yep. It's not going to do that.
RFID mark.
It's not going to do that because the code was written by you, and you think robots are our friends, and we can do cool things with robots. The code that you wrote is not going to turn on you.
But I didn't write all that code. He wrote some of the code. Chris wrote the code. I don't know. Maybe Chris is a robot.
He's not a robot. It's going to be totally fine.
Okay, maybe the robots just want to ride ponies.
What's really going to happen is the horses are going to take over because they're getting technology now.
Okay.
In a world where horses rule.
Where horses have NFC chips embedded in them.
Planet of the Shetlands.
And they can write code in Python. So he's working on the second RiderScan, bigger, better, horsier.
Yeah.
And that was on
Okay.
Show and Tell.
So that was a show and tell. For the folks that were on the show and tell, if you haven't already, let us know. We will send you out a sticker. We have these cool new stickers.
You have to put it on your pony.
Yeah, no, or you can do that, or your cloth or something like that. We have these stickers.
These stickers are glorious.
Yeah, and so if you place an order too, and you let us know.
Okay.
Lady Ada, tell us how people can be on the show and tell.
Go to my Google Plus page and respond to the thing where I say respond here to be added to the show and tell circle so that you'll be invited next week.
Okay.
That's it.
All right. So we're gonna do a couple introductions. We have some guests here. Kevin came in from France, and Matt is here from Brooklyn.
He traveled much further.
Yeah.
It's actually, you know what? We're more likely to be in France than Brooklyn. Like, man, Brooklyn is so far away. You gotta go over the bridge. You gotta take the J. Yeah.
Okay, so Kevin's here and Matt's here. These are the photos from our
photos like
page.
10 years and 20 pounds.
It's
That's
totally
cool.
fine. Okay,
yeah,
so
I mean, this is a low-res camera. They can't tell.
Kevin, introduce yourself. Tell everybody who you do, and then Matt afterwards.
Yeah.
Do the same.
Holler.
I'm the other engineer here at Adafruit, mostly working on like NFC and lots of breakout boards and
RF stuff.
Yeah,
Speak fluent French.
I like RF stuff.
Yeah.
Yeah.
And you're kind of known for ARM development stuff. Would you say that?
Yeah. I think most of my MCU experience is more on ARM. It's what I learned embedded development on, so I just sort of got lazy and stuck with what I know, and
yeah,
I just never really got out of that little box. So.
And then, what was the most recent board that you worked on that's in the Adafruit store that people probably know?
Oh, well, there's like
he
5.
did the gyro board.
Yeah, the gyro board, which we're going to show tonight.
Yeah, he did the gyro board. He's best known for doing the NFC breakout and the NFC shield. They're super popular, the best NFC development boards on the market, I think.
That's
I
right.
mean, there's like $500 ones you get from NXP, but they're still not as good.
That's why I made it.
Yeah, they're excellent. And
why would I buy a $500 board for a $5 chip?
In battle tested, there's a few NFC startups, and they exclusively use these boards because they're so good.
Yeah.
So
It's actually the easiest way to add NFC to like anything. So that's awesome, and it works great with Live NFC and all that stuff.
Okay.
So yeah.
All right, and Matt, introduce yourself. Tell us what you do and what you did.
Yeah. So I am the Director of Community Support and Evangelism. So I'd like to emphasize the community word, but definitely I'll be doing supporting and evangelizing in that whole mix. So you might have, if you are prone to obsessions with 3D printers, you might have seen me in the world of MakerBot, because I was the community manager there for a while. And I am here in my new haunts with these lovely people.
Go us, we're lovely.
Oh, thanks.
Yeah. Okay.
Your glasses fit right in.
Yeah.
Excellent.
Everybody has glasses over there.
Well,
Yeah.
I was told.
Because we're
to wear
nerds.
them.
I got glasses.
Yeah.
You can barely see your glasses. You've got these like super fancy glasses.
Is that better?
They're like
Cool.
they don't have frames.
All right.
All right.
Okay. So next up, Becky is probably going to come around on the other side here if she can. We're a little tight for space.
Becky's fingers.
And this is a project that Becky worked on, and it's a video. We'll show just a little bit of it. Hey, Becky. So you helped install some LED lights in someone's apartment.
Yeah, so like I don't have under cabinets. I don't have cabinets in my weird loft apartment, but these friends of mine over at the Diggs channel on YouTube have like this gorgeous apartment with kitchen cabinets.
That is a nice look. It's glossy.
Looks nice, right? Yeah, and their counter's really glossy. It's one of these new condo buildings in Williamsburg, but the we put use our RGB LED strip under the counter. We put the RF touch color wheel controller up above the range hood and made this beautiful color changing under cabinet lighting. And we have just a short clip of the video to show you.
Let's go to the film.
Go to it, and I'll paste the link in the
Roll
chat.
it.
In the cabinet.
Let's do it. So I'm going to drill a hole on the right side of this cabinet here where the wire is going to come all the way down to the base of the cabinet where the LED strip is going to be. And there's also going to be a hole at the base of the cabinet. And I'm going to do the exact same thing on the other side. So 2 holes, one at the top cabinet, one at the bottom of the base of the cabinet. So all these things now are going to go up in the cabinet. I'm going to put the ribbon cable, scrunch them all together and push them through the hole Shelly made. And then because your shelves are adjustable, they have a little bit of space between the shelf and the cabinet wall. So we're going to try to squeeze the ribbon cable down through that slot. I wired up 1/2 over here
of the LEDs, and we have another ribbon cable going over here, and Shelly's wiring that one. So when you're ready, Shelly, you can plug them in and see if they work, and we'll see if the colors are mapped properly. It's possible we could have some of the colors mixed up, so let's see if we've got green turns greenish. Yeah, there it is, green. Red is red. This obviously is way longer than we need it to be, so all I'm going to do is just, I mean, theoretically should do it while it's off, but I'm going to be super quick. Ready? Cabinet.
Let's do it. Right. So I'm going to.
All right.
Oh, it's glowy.
So there you go.
That's
it's cool.
So there's like that kind of video and cool under cabinet lighting now.
Yeah, it's really nice. So the tutorial there, and I made a blog post on the Adafruit site, which I'll also run over in Lincoln, has like the full bill of materials, but it's like a really easy project. And then since we filmed that, which we use the Euro terminal blocks, you can actually use the new solderless RGB LED strip clips that we got since we filmed that, and those make it even easier.
So no soldering at all.
No soldering, and not even a screwdriver, just an X-Acto knife needed. Super fun project.
Okay, Beck, you can stay over there for a second or so. I think we can all. I'll put
in
my
the chat.
Yeah, we'll get there in a second. So everyone, Make celebrated an 8-year anniversary of being announced. Where were you 8 years ago? Starting with Matt.
No, I don't want to answer that question.
8 years ago.
I like
Okay. So when is it now? So 2012.
What year was that, Phil?
2004.
2004.
2004. Sorry.
So let's see. I was probably working on some film project.
Okay. Kevin, do you know where you were 8 years ago?
2004, I think. I was working at Epson Engineering Europe, just outside Paris, in a job I hated, and I decided it's more fun to work for myself.
Becky's not responding.
Becky's passing.
I'm hiding her.
Okay. Where were you?
Actually, I know exactly where I was when Make was announced because I was in my office, the media lab, and Saul Griffith came by my office and said, hey, you know, my girlfriend's dad is coming up with this really cool idea for a magazine about makers. And I said, well, who's your girlfriend's dad? And he said, oh, Tim O'Reilly. And I was like, that sounds really cool. And he says, yeah, we should all write articles for it. And I was like, okay. And then I did. I wrote an article for the second one. I didn't get into the first because I didn't know about it until after the first one was already in print.
Okay.
So that's exactly where I was when it was announced. I was hearing about it being announced.
Okay,
so
mine's easy. I was working on Make. That was the easiest one. And did you hear about Make when it came out, Kevin?
I remember episode number 2 or 3 was when I was working at Epson. It's one of the things that made me think, you know, what am I doing in this job? I should be doing something I like, making stuff that I enjoy, and see if I can make a living at it. But it was actually it was Make like 2 or 3 was one of the first magazines I came across that made me think, you know, look, there's lots of people out there that enjoy this stuff. Why can't I be part of that? And I made microbuilder.eu maybe 6 months or a year after that, partly because of coming across Make.
And here we are all together now.
Exactly.
Aww.
I had a friend that had either the second or the third issue, and I remember it very distinctly because he wouldn't let me borrow it. I had to read. I had to sit down and read it right there.
Yeah. So here we are, very soon approaching 10 years of making. Decade-long movement, really taking off. Lots of changes, but a lot of people are still in it who were there from the beginning. Mm-hmm. Really cool stuff. My quick story with this, I had started Hackaday, and the folks from basically what was the Make team, it wasn't called Make yet, told me that they were going to be doing a magazine about making, and I thought it was a horrible idea, and I'm like, sign me up for it. Because I'm like, what a fun learning experience no matter what. And basically Dale gave me the keys to the Make site and said, go for it for the online stuff. Mm-hmm. And I handed off Hackaday to somebody else, and I was working on Make, on the launch and all the stuff there. So that was me 8 years ago. All right, so Maker Faire this weekend, New York.
I feel so
We'll
old.
see a lot of people. Okay, next up, mailbag. I'm going to do this one really fast. I can read this off. Every week we have mailbag. People send stuff. Pretty soon they're just going to send it right to Matt, and Matt's going to do this. You're in charge of mailbag now.
Yep.
Go, Matt.
Yeah. Jim writes in, I've just finished assembling a number of kits from various suppliers. Your kit assembly instructions and the quality of your PCB are head and shoulders above other suppliers. Putting together an Adafruit kit is a pleasure.
Yay!
That's from Jim. We love hearing that. Okay, we're going to go in turbo mode here. Some news in the wonderful world of open source hardware. We all like open source hardware. On the cover of this Wired is Bree. He has.
It's not me in different makeup.
It's not, yeah. So this month's Wired cover has Bree, known for the Cupcake, for Thingiverse, for Thingomatic. And
for Make Projects,
yeah.
Make Video, or I don't know, what else is the name of
Weekend
it?
Projects.
Weekend Projects.
Yeah. I convinced Bree to quit his job as a school teacher to come work at Make many years ago.
About 8 years ago.
About 8 years ago and all that. So lots of interesting things going on. I know that there's a lot of conversations about open source hardware and this new MakerBot. Adafruit has a statement that we're going to debut tonight, and we're going to probably make it a t-shirt. Just to get it all over with. This is from Lady Ada. When people ask us about open source hardware, she says,
"Oh, really? There's a debate about open source hardware? I'm going to keep shipping open source hardware while you all argue about it."
That's our official statement on open source hardware and what we're doing. Okay.
Fritzing Friday.
Fritzing Friday. So these are parts that John Engineer
does. Does an awesome job.
Does
yeah. Do you want to say what these are real quick?
Yes, these are our waterproof Momentary and on-off switches. We have 2 types, and we have them in 4 lovely colors: red, green, blue, and white. So we had them originally only in like green, and then people were like, "We want all the colors." And as I get those colors, I'm like, "Well, we want the Momentary and on-off," and so we got them all. And they're really great buttons. They're rugged, and they're fairly inexpensive. They're panel mount, and of course they have the LEDs built in.
Okay.
We also have the breadboard power supply kit that we designed, adjustable breadboard power supply. We have the rotary encoder with built-in switch in the middle there, and on the right we have the NPL 1115, I believe, A2, which is a low-cost barometric pressure sensor. We also added in the Maxbotics sonars. We don't make these, we simply sell them, but they are fantastic, and that's why we love them so much. We have a full range now, and so for people who want to use them in their projects and want to document how they are arranged, we have them both in the green, which is the standard, and black, which is the high resolution.
Okay, and we'll be seeing John Engineer tomorrow. We're going to meet up at the MakerBot store. John Engineer is interesting to me because he's an artist and photographer. Some artists use paint, some use canvas. He uses Fritz right now, so we'll see him tomorrow. Actually,
yes.
We're gonna all get together and do that. Okay, moving along on. Some news in the world of Raspberry Pi. Raspberry Pi had a event. We went to it. It was the NYC Resistor, Adafruit Industries, Newark Element 14, Raspberry Pi, American Pi Hackerspace Tour.
We had pies in the eyes.
Yeah, here's a photo of Becky with Pi eyes. Here is Lady Ada with the Raspberry Pi light painting.
Yeah, I just had a mop handle with a meter of LED strip, and I loaded up our example code, and
look at that.
Yeah, it's kind of cool. It's colorful.
And then Matt, you might know a little bit about this project because you blogged about it. This was the winner of this giant bag of Raspberry Pi stuff. It was a stoplight controlled by a Raspberry Pi. Do you remember anything about that project?
Oh yes, it's a really cute project. So they were experimenting with a lot of stuff that has to do with a lot of people jumping online and participating, and so it's sort of people can pick which light they want to light up, and this ends up getting summed, and you know the light actually changes. They have this really cool traffic light they picked up in a I think like an antique store or something upstate, and it was really pretty cute. So they were excited not only because they got the thing up and working with some simple code, but they're going to be extending this, and they're testing a lot of possibilities for participatory projects in the future.
Very cool.
Yes.
Stoplight is the new payphone, I think, because a lot of the older ones are getting replaced.
Yeah.
And we got payphones for our weird projects. One bit of data I wanted to pass along, and I made sure it was okay with the Raspberry Pi Foundation. So a lot of people ask how many Raspberry Pis are out there.
1, 2.
Yeah, you can't count them. It'll take too long because here is the quote. This is from Eben Upton. We had hoped that there might be about 10,000 units in the first year. So far, it's been 400,000. People love it. And the foundation has, because I wanted to double check because they said this actually at the event. They said that there will be 1 million shipped within a year. And so right now it looks like there's about 500,000 and they're shipping maybe about 50,000. A while ago, I wrote some articles about Arduino. I like to keep track of all these things because lots of people like to quote it. So I'll have an article later about this. But people really want a low-cost Linux computer to teach computer science to young kids. And looks like it's working out.
It'd be great to see that geographically sort of separated. I don't know, it's not really possible, but I'd be really curious to see
I think
geographically how that's...
everybody in the UK, I think, has to get one.
Exactly.
Especially now that they're being made there.
It's part of the nationality test that they're introducing after 5 years of residence in the country. If you don't own a Pi, you're out.
Okay, and Kevin, we bought you this thing. You have to. What did we buy for you?
We'll do a video demo. We'll do a video demo, but people want to know what is this thing.
What is this thing that you got?
Which we just gave you like 5 minutes ago, so you haven't even turned it on.
Yeah.
I haven't hooked it up to anything yet. It's a vectored network analyzer. It's basically it's a pretty specialized tool, but it's kind of a must-have if you want to do any serious RF development. If you look at something like that NFC shield that we have, the reason it's good is because it's properly tuned. And you need a tool like a vectored network analyzer to do that. Basically, how it works is all of those RF signals get transmitted through some lines, and they have to match an expected impedance of usually it's 50 ohms. So you have to make sure that the antenna is at 50 ohms, and also sort of the receiving end on your chip is at 50 ohms. And it's frequency dependent, so you need to make sure that at 868 megahertz or 915 megahertz or 2.4 gigahertz or whatever, that the trace that you're transmitting those signals on matches 50 ohms. And the only way that you can effectively measure that is with a VNA.
So the VNA injects 2.4 gigahertz in,
yeah.
For example, and then it sends a signal. Looks at the reflections.
Yeah, what it is it sends a signal at that frequency, and then it switches into read mode, and it checks sort of the reflections to see how much of your signal is sort of bouncing back, because you don't want any of that signal bouncing back. If you want to have good range on your antennas, you need the impedance to be perfectly matched. So
any signal you send goes straight.
It goes straight out. That's for the maximum power transmission. If I'm sending out 5 dBms worth of energy out onto the trace, if I want that to actually go, all of that energy to go out, it needs to be perfectly matched. Otherwise, what happens is I send out this signal, some of it bounces around and it comes back and it's bouncing back and forth, and maybe only 70% of the energy that I'm sending out is actually radiating out where I want it to go. So it's similar with batteries. If you need to have the two signals matched up for the maximum transfer of power. You have the same issue with solar, with MPPT. You need to make sure that both ends of your cable, in a sense, are matched up for the maximum power transfer. So you use a VNA just to do the impedance matching so that you get the best range. When I started with those NFC shields, I had a terrible range of like 1 centimeter, and the reason that we have the maximum range of 10 centimeters is simply because sitting down for a day or two to really painstakingly get that perfect match, because you have to sit down, you have to take your box of really very precise valued inductors and capacitors, and you just sort of pull it off.
It depends on like exactly what your antenna trace is. I mean, you follow the diagrams in the data sheet, but it's still
there's always variability.
There's variability on like how the thickness of the copper and the thickness of the PCB, and then the components you use, and each one of them, you settle on components, but there's always a little bit of variation. And the layout affects it too. The parasitic capacitance of like this ground plane.
There's so many factors that go into whether.
And at 2.4 gigahertz, the picofarad makes a big difference.
Yeah, that's why it's called a vectored network analyzer, because you're actually analyzing a whole network of parts, including the parasitic capacitance on your little leads. You want to use tiny little parts to reduce the parasitics, but you use an instrument like this to measure that whole network of factors to determine the impedance, because it's your trace width. There's calculators that you can use where you can plug in and say, okay, I'm using FR4, 1 ounce copper, 1.57 millimeter thick isolation, and it'll give you, okay, you need it at 950 megahertz, that means you need a 70 mil wide trace. That'll get you close to what you want, but there's always some variability, and if you really want the maximum range, this is the only way to really get that. So it's
otherwise you just lose the energy. It's not you know, if you don't have the range, it's not like, oh, the power's lower. You're just burning that power out.
It's just
wasted. So yeah, it's an expensive tool. These cost $12,000.
You could buy a car for.
Yeah, it's a $12,000 tool. But this, I mean, it's actually a fair price for V&A. I thought they were.
This is a great machine. If I've been looking around for years. I don't have one at home simply because it is such a substantial investment. But this one's actually a really good deal. I would say if you want to get a new vector network analyzer, before this model, you'd be looking at probably around $20,000 would be a good entry-level unit.
Does it do anything else, or just spectrum analyzer?
This is basically just a VNA. They do have a spectrum analyzer that's same package and everything, but it's a different model.
Yeah, okay.
But this one is this model goes up to 4 gigahertz. They have a 6 gigahertz one, but it's not that useful to me.
For most people, they don't usually go beyond 2.4. Like most people are
for
doing stuff
Wi-Fi,
in the
Bluetooth, and sub 1 gigahertz, like 434, 915.
Well, that's this is what like commercial and manufacturing. I mean, if you're military, of course, you need you have full ranges that they use, but for commercial use, there's only certain frequencies that are most common.
This is actually designed for military use, so I get to feel like a. I have to wear camouflage when I'm using it.
This is a serious tool for serious business, for serious engineering. This just means we're going to have some really cool products coming out soon.
Yeah.
When I see these tools, I'm like, Kevin is testing something very delicate, important, and crucial, and complicated.
They're sending me to Afghanistan. Don't listen to them.
You used to rent it, and for most people it makes sense. But we're
$1,500 a week, so for $10,000.
It's also we're starting to have like 4 or 5 RF projects, and like we revise them and spin them and make different versions, and like there's maybe an Arduino Shield version, maybe a standalone version, and before you know it, it's like you've already rented one a couple times, and we're like, okay, well, let's just get you one because it's just if you're using it that much, it makes sense for us to have it as a resource. But you can rent them from places. It's like a scope. It's like if you use it enough, you should just buy one.
It actually makes Matt's job easier because customers aren't going to say, why doesn't this thing work?
Yeah.
Like we actually are going to go and do all this testing, and you've hit the theoretical maximum on your projects before, the RFI.
Yeah, if it was without an amplifier.
Yeah, that's awesome.
Yeah, just a basic question. How do you know it works? I'm going to say, there's this thing, and he knows how to use it.
We're going to send a time-coded link.
Chart, Mr. Smarty Pants.
Yeah, we're going to send this video and say, this guy did this, and he knows what he's talking about. Okay, we're going to keep moving. Lady Ada, there's some things in the new Adafruit learning system this week. We released
some new tutorials.
Yeah, updated tutorials. Okay, what are these?
We have the Pi box, which Becky did. Yay, Becky. We have the bone box. I think also Becky did that one. Oh no, did Dragon do that? I don't remember. Okay, Dragon did that one. Dragon also did the LED pixels, I guess. Okay. And also the IR receiver, which we wrote some code for, and some OLED updates. I guess did we do this week? I guess so.
Yeah, those are all updated tutorials this week.
Yeah, we have a lot. We're slowly moving all of our tutorials to the learning system while we're also doing everything else at the same time.
Okay, and for folks, because we have new folks all the time, what is the Adafruit learning system?
It's the best way for me to write tutorials for people to read them.
It's awesome.
And Kevin, you've used it so far, and Matt, you're going to start using it soon. So
it's basically the solution to how to write tutorials for people fast, so that they can read them fast, get PDF downloads, have them linked to products, have everything dynamic and easy to use, mobile ready. Okay. You can embed videos wherever you want, content however you want to do
PDFs, RSS feeds.
It's flexible but powerful.
Yeah. And where can they go to see it?
They can see it at learn.adafruit.com.
Okay. All right. Just a reminder, the code is KTownGriff, 10% off. I bet you guys didn't expect to be a discount code tonight. 10% off.
Yeah, that's great.
In the Adafruit store.
Or we might have to start a band.
KTownGriff.
Like a hip hop.
It's a metal band.
You're definitely vocals. You're the bassist.
No,
All right. I hit the wrong button.
Well, it's time.
Yeah, so no, it's actually time to do new products. Yay. You guys ready for new products? We're going to have a jingle in there. New products.
New products.
All right, all the stuff is new products. Because we're tight on time, Lady Ada.
I won't use the overhead. I'll just talk about it.
What I want you to do is talk about this. I'll introduce it. So Circuit Playground 1.6 is out.
Oh my god, it should not end.
It is a massive update. So
unbelievable.
Tell
we
people
have
what these screens are.
Heatsink Calculator. You want to calculate your heat sink based on the ambient temperature, the power you're dissipating, the thermal resistance of your case, of your die, of your heat sink, of your everything. go for it. Use this calculator. It's so easy. It'll tell you if your heatsink is good enough for what you want to do. Next up, we have a quarter wave calculator. For when you don't have a VNA and you're like, well, I just want a piece of wire to do this job for me, which I've actually done a couple times. If you're doing like an FM antenna or AM radio antenna, well, AM radio probably not, but FM antenna or you know, you're using like for like a 900 megahertz or 450 megahertz or something, or even a 2.4 megahertz. You want to know how long to cut your little piece of wire. This will tell you, and it'll get you pretty damn close to 50 ohms. Next up, we have a voltage divider, resistor divider calculator, so you can calculate, you know, the voltage in, out, whatever, based on your resistance, or calculate the resistance based on the voltage you want. It's all around voltage divider calculator. We have a color to wavelength calculator. So you're like, I have this frequency of the wavelength of my E&M stuff, but I want to know what that looks like when it hits my eyeballs. This will tell you.
Burns.
It burns.
The goggles, they do nothing.
We have a pinout. We have a whole bunch of pinouts. I mean, it's on NVMe of RS-232, RJ45, VGA, Raspberry Pi. I think we have Arduino chips still. We have Max 232, 78L05, 7805s, more stuff. I don't remember. Trace with calculator. Also, when you want to know, this is not for the impedance, but this will tell you your power dissipation. So if you're like, well, I have an amp going through this, and I want to make sure that I have a thick enough trace, it will tell you your trace width and voltage drop and resistance. So it's all good.
Okay, and this last one, this is an enhancement to the show and tell feature. So if you have the app on an iPhone or an iPad, you can take a photo of your project or use any photo from your camera roll, and also videos now. So you can send Adafruit a video or a photo and multiple attachments to us, and we post it up on the site. And we've been giving away stickers and stuff like that.
Yes.
K-Town, you're an engineer. Is this K-Town approved? Is this a good app for people?
This is K-Town-licious.
Okay. All right. And then does it work on the new iPhone 5, Matt?
You have an iPhone 5?
Yeah, it just arrived today.
He waited in line 2 days for that.
You have the white one. Wow, that's kind of cool looking.
Yeah.
Okay.
And
it's working just great. I recommend it. And I'm wondering, I don't know for sure if this will work, but if you're looking at putting, you know, hitting some RGB LED lights with a color, you want to check to see the enclosure, what it will look like with the light spell.
Oh yeah,
this should work.
Yeah, you can put it in there like that.
So you get,
I see.
Wait,
So like
maybe
that's
this,
what,
you know, this is going to reflect a lot.
Okay, great.
Very cool. And just a reminder,
LED simulator. They probably didn't think of that when they came up with the iPhone 5.
The cost of the app, you get a coupon in the app, so it's basically free. So,
Yay!
Yeah. And it's doing really well. Educators are picking this up a lot. It's being used in schools quite a bit. We got emails from teachers.
Someone wants a K-Town-licious badge.
Working on it.
Okay.
I'll lick it personally.
I'm talking to his agent.
That's so gross.
We're signing the rights
Okay.
soon. Okay, so that is a new product-ish because it's a download.
Yeah.
Okay, let's keep
Some
moving on.
products or software.
Yeah.
This is just a 3.5 millimeter stereo to RCA jack. This is some people were asking for this for the Raspberry Pi because they want to plug into their TVs, like they have HDMI TVs or NTSC TVs and they want audio. We also have this is a sharp distance sensor. We've already carried the 10 to 80 centimeter sharp distance sensor. This is the one that does like 20 to 150 centimeter or something. So it's just a longer range. It's a little bit more expensive, but these are really, really easy to use. They're very popular for beginner projects. We have panel mount HDMI cables. We had to look very far and hard for these cables because these are definitely weird. But it's basically an extension cord with and they have these molded ears on them, and so you can panel mount them. It can't be too thick because the cable has to plug in, although you can mount from behind too. Like you could attach an M3 or I think an M2 metric screw from the other side. That's kind of handy. Okay,
and then we have a couple of Raspberry Pi related things, and then we have one new special breakout board. I have that camera thing going on tonight. The Raspberry Pi stuff we have is the Pibos are now in stock. These are beautiful cases.
Yeah.
And maybe we'll go to the overhead in just a second. So these are the rainbow colored ones, and these are in stock right now. And then
we also have the super special
edition.
And
then they sent us a limited edition one, and they said that they had enough plastic for more. So you'll be able to get an Adafruit one soon. So I'm going to go to the overhead with Matt. So this is the Adafruit version.
Yeah, it's like cool blue. I kind of like it. It's like this translucent blue.
Yeah. So they have enough plastic to make 50 of these. So we might do a limited edition version of it.
Okay. Yeah, it's got the, we also have the little card adapters in, and I think we put them in the store this week, yeah?
Yeah, we sold out, I think.
We sold out. Well, we're making more, so we have the little low-profile adapters. That's why you don't see the card sticking out, because on the bottom, if you look carefully, yeah, it's got the little adapter, but it has it built in, so if you turn it upside down, yeah, see it?
Yeah, look at that.
So you can put a micro SD card in, so you don't have a SD card sticking out.
Yeah.
Little
Okay.
card adapter.
And
Also designed by K-Town.
Yeah. Good job on that. All right, and next up, this is a really exciting product because it's so cool we can't ship it out of the country. So this is the new gyro board.
Yeah, so we wanted to have a gyro board. People were asking us. We have accelerometers. So this gyro is based on, it's just like the latest gyro available on the market from ST. It's the L3G D20, which is full 3-axis, so it does X, Y, and Z. It has adjustable scale, so you can do 250, 500, or 2,000 degree per second scaling. We had some space on the breakout board. We wanted to have 4 mounting holes so you could attach it really solidly, because like we'd seen gyros that had like 1 hole in them, and it's like, well, if you're measuring twist, you don't want to have 1 mounting point. You want to have at least 2. And we actually just went and like splurged for 4. It does SPI and I2C, and we have an example code for the Arduino that uses both. So you can use SPI if you want to, if you have a microcontroller and you don't want to use the I2C pins for some reason. I2C is the easiest, it only uses 2 pins. There's a data ready and interrupt pin if you want to use those. We don't have it in our example code because we don't care too much about that speed or interrupts, but check out the data sheet for more details. It's a great gyro. It is perfect for any kind of like inertial measurement, or if you're doing like a 3D motion capture or something, combine it with an accelerometer, and you've got like lots of motion capture stuff you can do.
And let's go to the back of this. K-Town, can you explain what all these things are, what they mean? And maybe we'll go to the other head after that.
Okay.
Do you know what all this means on the back of the board?
You put it there.
Yeah.
You gotta tell
That was like 3 weeks ago.
No pressure.
Basically, yeah, you can control the sampling rate on the chip depending on I think the resolution goes down depending on the sampling rate that you choose.
Well, there's a high pass and low pass filter built in as well, so you can set that. But yeah, I think it probably has a fixed resolution. Like, you don't get better resolution; it just gives you better scaling.
They want to know what the sensitivity is.
Check the data sheet.
Yeah,
I don't have it off the top of my head what the sensitivity and the drift. It's like obscure.
It is actually, when I was testing these out, they are fairly consistent. There's not like this huge spread when you're in a static position with the range. I've tried some other chips where you move it a little bit and you have this gigantic jump.
Yeah,
so
but it just seems pretty smooth. But it does have full 16-bit resolution, so divide that by degree per second, and that's the resolution.
Because I've seen some 16-bit accelerometers or ADCs, and it's just a marketing number because
the last 4 bits are noise anyway.
You can spit out 16 bits on any chip, but if it's not a good 16 bits of data, or if it's not at least a good, say, 12 bits of data, then it's just a marketing number that somebody looks at. But it is. I did find the chip fairly stable in the readings, and it's not the case for some other chips that we have tested. So.
Yeah, it's a pretty good gyro. So I think this is like, I mean, it's a digital gyro. I'll look for analog ones as well, but this is pretty much the one we decided on.
And just to be clear, why can't this be shipped outside the U.S.?
Well, we purchased the chips from Future, and they said these are export restricted. So
some things are export restricted.
Until we figure out exactly why and what, we're just decided like, well, we'll just make it really clear, like you can only purchase this in the U.S. We'll figure out exactly what the export restrictions are. We'll do more research about it, and if it's something that we can export, we will. But we just want to
we follow the rules.
Follow the rules to start, and then figure out what exactly the rules are.
Okay.
It is complicated. I think for things like ADCs, there's restrictions on anything above 16 bits, and it is pretty complicated.
But it depends on like what it is and if it's a certification. So we have to you have to look it up.
It is pretty complicated. I've seen products in companies that they spend $1 million on something made for the Chinese market. I saw this with some wireless base stations for GSM. The company spent millions of dollars designing them, and they couldn't ship them because they found out later because of some export restrictions.
Oh, wow. Maybe Matt can show the size of this thing on the overhead real quick. I'm on the overhead. Yeah, so see the small board too.
I also have one attached to a Arduino back there if you want to pick it up. Yeah, right there.
Yeah.
So that's attached. So it's fairly small. I mean, all the level shifting stuff does take a little bit of space, but It's a fairly expensive chip, comparatively. So adding, a couple of chips and components to make it 5-volt safe was worth it, and it's 5-volt compliant both on I2C and SPI.
The icons came out good as well.
Yeah, the icons came out really nice. The silk screen came out nice.
Okay, those new products. We did it.
It was new. We showed it off.
Those are new products. Okay, so we have some top secret stuff.
Okay.
Top secret. It's not out yet. Don't ask.
Don't ask.
Don't ask questions about these products.
Don't ask.
First up,
Secret.
Lady Ada, briefly describe what the web ID is, and then we'll show a quick video.
Oh, okay. Wait, hold on.
Take some water.
Yeah, the Web IDE is a new project that we're doing. So we're pretty satisfied with the Learn Adafruit system. And that's a tutorial system that we want to use to show people tutorials and how to do stuff. But it still isn't a direct, educational system. So we wanted to actually build something that was an actual learning system for people to follow to learn electronics. And so what we decided to do is use a Raspberry Pi because they're easily available, they're low cost, and they have a fairly powerful Linux computer that can run a Linux compiler and have Wi-Fi and stuff. So the idea we had is we really like the ease of use of the Arduino IDE because it's so much simpler than using Eclipse or even the MPIDE or whatever. But we wanted to have it for Python because we think that Python is a little bit easier to learn for beginners. They don't have to deal with pointers or stuff like that. And we wanted it to be completely web accessible, so you didn't have any drivers you had to install. So basically, instead of having to download software, install drivers, find the COM port, all these things that were very difficult with the Arduino, it seemed very simple. How hard is it to figure out which COM port your Arduino is plugged into? Turns out it's actually very hard for a lot of people. Or which driver do you download? There's one for the Leonardo, one for the Mega. So the nice thing about this is that there's no drivers or software to download. Instead, we'll eventually have an SD card that comes with the Raspberry Pi. You plug it in, you boot it up, and then on your laptop or your computer, you can just go to the Raspberry Pi web server, and it will start up in this basic, simple IDE. And the IDE is written in Node, Redis, and a lot of JavaScript, of course, and I think some Ruby as well. Basically, it's a simple IDE for writing Python code and running it direct from a web browser.
Okay, so here's a screenshot, and then we have a very short video that we're going to show real quick. All right, Lady Ada, you're going to show me a demo of the Adafruit Learning System Raspberry Pi Web IDE. This is a preview. What is this?
.my.com. Yeah, so we're working on this Web IDE, and the idea is that you'll be able to write all the code you want for your Raspberry Pi and use our awesome example tutorials and libraries, and you won't even have to open up an SSH client. So I've got the web browser running here, and for example, I'm going to try the BMP 0885 example code for the barometric pressure sensor. Yeah. So we got this really nice color-coded, comments are purple and strings are green. And then over here, I've got my Raspberry Pi.
Just to be clear, this is running on the Raspberry Pi.
Yeah, this is running. This is the web servers on the Raspberry Pi, and it's running with Ethernet connected. And I've got a cobbler, and I've got one of our barometric pressure sensors. Okay. So then I don't even have to log in or anything. Through the web browser, I click Run, and it will open up a terminal and run the program. And it is 26 degrees centigrade here, and we are about 100 meters above the ground.
That's cool. All right, Lady Ada.
Yeah, so all of it, the thing that is a little confusing, but well, of course when we fully document it'll be clear, is the IDE is a web server running on the Pi, and then you use any computer's web browser, like your Mac or your Windows computer or your Linux computer on your desktop, to connect to the Pi to run commands on it. So basically you don't even have to SSH into your Raspberry Pi. You can just plug it on your desk and plug an Ethernet cable in and then connect to it. So you don't even use USB or anything. Okay,
we're going to keep moving. We have a hardware. It's not out yet. Don't ask. So maybe we'll do that one. Are you set up for that? The MP3 thing? Did you want to do that?
Oh,
or did you want to not do that?
I don't know if we have time. Maybe we'll do it next week.
Okay, I think we're going to try to get the questions. So I have...
Oh, you don't want to show the other stuff?
Yeah, we do have other stuff. So instead of...
show it next week.
Yeah, we'll show it next week. So, real quick, we do have one video that we can share about our new Adafruit headquarters. Here it is. Today, we tested the bell.
There's a bell.
Okay, Lady Ada, I want you to test our bell for our new Adafruit headquarters.
This bell?
That bell.
Okay.
Okay. That's a bell. All right.
Ring, ring, ring.
Okay.
It was hella loud.
Yeah, so the bell is loud.
Is it actually a bell? Like, there's a bell.
It's one of the last things in the space that has to be built, this bell. So when we get deliveries, they buzz the bell. So that was today.
So there will be no confusion about whether there's a bell or not.
Okay, so
Did the bell ring? I don't know. It was so loud. How did you not
Sometimes
notice?
we have trouble with that. Sometimes you can't hear the doorbell and it's a problem.
I know.
Yeah, and
well,
then,
we solved the problem with the bell.
You can see the walls shaking when it rings.
Am I ever going to do video?
yeah,
Bring.
it'll be fine.
We'll be all meditating and bring.
And then we're still working on plushies. Here's a photo of them with the tags on them. Coloring book is coming out shortly. We have a printed copy. Matt, maybe you could show it on the overhead over there. Look, the first physical copy of E is for Electronics.
It only took 2 years.
Yeah, it's fine. These are all the illustrations, and you'll be able to color all the letters and explore history through electronics with Lady Ada as your guide. MOSFET stops in too. So this will be out shortly, and it'll also be a free download because we're crazy like that.
Crazy.
Okay.
Crazy Lady Ada and her crazy downloads.
So do you want to go to questions?
Yeah, we can do 10 minutes of
we got
questions.
10 minutes of questions. Okay, it's
Yeah.
question
I
time.
haven't seen this yet.
It's question time. Ask your engineering questions. What's the first one?
I got one. You ready?
Yeah.
Okay. MJ Lynch from Ireland, it's his first time watching, writes,
You should be in bed. It's 3 a.m.
Yeah, I know, right? I'm building an arbitrary signal generator. This will be used in the end to generate plasma. I plan on using a high sample DAC for maximum something. I also would like to have a touchscreen LCD control as well as the ability to read signal files from a USB memory pen. I'm wondering, would you suggest the Pi, BeagleBone, chip kit, or even the Arduino as the main processor?
If you want to do a high-speed DAC, I mean, it depends on how high-speed it is, but probably the BeagleBone will be the fastest.
I'd say BeagleBone is going to be the most flexible.
That's probably going to be the fastest one, but because if you want all this stuff together, it adds up. There's a lot of things involved. And there's touch screens available for the BeagleBone already.
And if you want USB hosts to be able to read stuff, you'll probably need a BeagleBone or a Pi anyway. You can.
Because the Pi doesn't have
there's a shield for Arduino, but
the Pi doesn't have enough GPIO to do high-speed DACs.
yeah, I think it's the BeagleBone would make them. To me, the BeagleBone would be the first thing that would pop in my mind.
Although SPI DAC, you could probably do SPI from the Pi pretty fast. I don't know. It depends on what fast is. Lots of Pi people say fast, and it's like, well, it depends on. Some people fast is like a kilohertz, and I'm like, that's not very fast.
Okay, next up, question for K-Town. What are your predictions about the future of NFC? Any thoughts on why Apple may have left out NFC on the iPhone?
Yeah, I don't know. I was a bit surprised. Yeah, I think it's sort of everybody talks about it, but I think people are still waiting for that one compelling reason that forces people to use it. I just haven't seen that one application that or that one big company like MasterCard or Visa or American Express or something that I think the technology is there. There just isn't that compelling solution, I think, or at least the momentum behind it with some really big company that's going to sort of put some weight behind it. I think it's some big credit card company or payment system really has to get behind it maybe a bit more than has been the case until now.
My prediction is much like music, when Apple has gigantic deals with Starbucks and San Francisco Transit and New York City Transit, that's when they'll finally put a chip in. It's all about business deals, not about technology anymore.
You need it's not the technology. It's
been around.
It's like 15 years old, or
so
you need the retail ecosystem around it,
Yeah.
and there just hasn't been the adoption there.
Yeah, they gotta buy Square and then add or something like that. Okay, Pi question. Can you break up the digital audio from the Pi if you're not using the HDMI port for audio?
The pin 18, which we have, the PWM kernel module we have, does give you access to one of the audio channels, but it's not filtered. It sounds like crap because it's the unfiltered one. So if you don't mind filtering at all, you can get audio out of one channel of audio through GPIO 18.
Okay. Next up, can you tell a GPS which satellites to sync with?
No.
No.
Okay.
It's a one-way communication.
All right. Any plans for a new ARM board like the LPC 1343 or TNC 3.0?
We'll be carrying the TNC 3.0.
Okay.
I got one.
Yeah.
Who made the Raspberry Pi IDE?
It was Justin and Tyler and myself and Daigo and a lot of the Adafruit people all working together. All rocking out.
Yeah. Oh, someone wants to know what our thoughts are on the replicator. We have a quote.
Really?
Yeah, everyone's debating about open source hardware. We're just going to keep shipping open source hardware. Everyone debates about it. That's our thoughts on that.
Okay. I have one engineering question.
You feel like reading it?
I am reading it. I don't have my glasses. I want to use a TI TLC 5940 in the GFN package. In the datasheet they say I should use vias with the thermal pad in the center of the chip. Would it work if I'd only designed the thermal pad?
You can, but it depends on like how much current you're drawing through it. You do have to calculate your power dissipation through the package, and then look up the thermal resistance of that package. It's probably in the data sheet, and then you can use a thermal calculator, or just do it by hand to figure out whether you're going to be dissipating too much power. But you know, you can put a heatsink on top of it, or it's pretty small. Probably just put vias underneath the thermal pad. To a ground plane as they request. It's in the data sheet, you should probably do it.
Usually most of the manufacturers, they give you really specific advice about the paste layer, where to put your vias as well. So you want to have your vias sort of draw your paste layer so it doesn't overlap with your vias, but usually TI, I know, is usually pretty good about this, that they give you some pretty specific suggestions for your
We should probably take the
package layer.
suggestion.
Okay, next up, will the web IDE for Pi be open source?
It's not out yet, so don't ask.
There you go. Next up, is there a 3D printer in Adafruit's future? Well,
yeah, I'm bringing. I think I'm bringing a couple. I'll definitely bring a replicator, and probably a Thingamatic that I'm using usually to pin plot. But they will be available, and I'll be fixing your up.
Yeah.
So they'll be printing here.
Yeah, we'll try to do some 3D printing.
Okay. Next up, someone wants to know what are we looking forward to at Maker Faire? Seeing makers and friends.
Yeah.
It's always what we're looking forward to. Anything in particular that you guys know that you might want to see at Maker Faire?
Well, I mean, I have to admit, I know I'm coming off of a lot of focus in 3D printing, but 3D Printer Village is massive this year.
Yeah.
There are going to be so many new, interesting things to see there. So I'm planning on spending some time there, seeing stuff I haven't seen before, and new versions of new tools. And a lot of demos, like technology demos. People, these technologies have reached the point that people are doing more and more interesting things, sophisticated things with them. And they're just coming and showing that kind of thing.
That's cool.
I'll be there too with the Madagascar Institute dueling mechanical bulls.
Yeah, I want to see Becky in her outfit.
Yep,
okay.
outfit.
Next up, what's the difference between a 50 ohm and a TTL output of a function generator, and what do you use one? What uses one of the other? When do you use? When do you use one or the other?
Function generators can give you signal output, so it's like 0 to 5 volts, or they can give you 50 ohm output, so it's assuming that you will have a 50 ohm load impedance.
Yes, if you hook it up to an oscilloscope that's high impedance, you'll need to.
Yeah, you'll notice that like the voltage will be off because it's expecting a different impedance. So if you're seeing infinite impedance, I think it'll be twice as.
Yeah, it's twice. You'll see twice as much on the scope, or is it half? Ooh.
It's one or the other, but basically you'll be like the VPP is wrong.
Okay. Is there an open source laser cutter out there?
Yeah, I think Laser Solar weren't they open source?
Yeah,
there's a bunch of projects.
There's a Kickstarter one.
Yeah.
Laser Solar.
Yeah. I don't know if they exist yet though. They do.
Yeah. Okay, next up, I want to run a less than 1 inch OLED display from a Yo-Yo. Any suggestions?
Any of our OLEDs are as small as they get, and they're all. We have a bunch that are like 0.95 inch diameter, diagonal, and they only draw like 20 milliamps. So yeah, we have SPI and I2C code for all of them.
Okay, and we forgot to talk about the new accelerometer, so someone has a question about it.
Oh, shoot, that's right. That was last week.
Yeah.
Oh, but we had Woz on the show last week. That's why.
Yeah, so someone wants to know, is the new accelerometer a lot more sensitive than the older one?
Is it more sensitive? It has a wider range. So
16 Gs.
16 plus or minus 16 Gs, so it's actually less sensitive because it's a wider range. So the trade-off is it's 16 instead of 3. So per ADC bit, you'll have a bigger step, right? Because you have a wider range. But 16 Gs is good for like rocketry or like colliding things together. Yeah, it's definitely much better. We also have a 200 G one that we're working on, but unfortunately the chip doesn't exist yet. But when it does exist, we'll have a 200 G accelerometer. I don't even know what you need 200 Gs for. That's
Okay.
It's like a special Neil Armstrong edition of the chip.
That's a good idea. Next up, any plans for a 3 or 4 stepper motor driver shield?
We're working on stepper motor stuff. We're slowly but surely getting into more robotics and mechatronic stuff. We want to do it right. As people who are aware of Adafruit history, we don't always get the first thing out the door, but whenever we get something out, it's definitely the best. So
yeah.
You know, when we have stepper drivers and more motor shields and DC motor drivers out, they will be really well designed.
Okay. Next, when do the results of the entrepreneur thing get released? We won't know probably until
January.
December or January.
Yeah.
That's the way it is. Thank you everyone for voting for Lady Ada for Entrepreneur of the Year.
The votes.
I think it has to do with their print schedule.
They have to, it's like they won't tell us until it goes to print, and that's months from now.
Okay, is there any way to get around a polyfuse droop when designing a USB PoER circuit similar to the Raspberry Pi is having a problem with?
The Raspberry Pi is actually not having a problem with USB. They actually designed it correctly, but people just weren't paying attention and they wouldn't listen, so they actually had to undo what I would consider actually a pretty good design practice, which is you shouldn't let your USB draw. You shouldn't let your entire design draw more than 500 milliamps, which is what they were trying to do, but like nobody cared. They just kept plugging stuff in, and they were like, it doesn't work. If you're having polyfuse droop, you should spec a different polyfuse. I mean, it's a fuse. Like, if you're sticking a quarter into your fuse slot, like you made a mistake. Like you shouldn't be doing that. You should redesign your layout or power supply.
All right, we're going to do one more question, and we're going to run a couple minutes over, but we're going to just go for it. How much ADC noise is on the AVRs?
There's some really good tutorials about that. It depends a lot on what you're doing, what your AREF is, whether you're running other stuff at the same time, what power mode you're in. We have posted a bunch of notes about it. I know also Open Music Labs did a tutorial about how to get your best ADC response out of the AVR. And
then one last question, unless it's going to be too complicated. When using a thermistor, how do you decide what the coefficient to use in the calculations, i.e. B2585?
It's in the spec.
Spec.
It's whatever spec it is. Okay, that's it.
Okay, that was it. That was fantastic. Those were the trivia questions.
Okay.
No, sorry, those were questions.
Questions.
Now we're going to go to trivia questions.
Trivia question.
Yeah. All right, Lady Ada, what are the rules?
The rules are, if you won a fantastic prize, you cannot win another fantastic prize. We only have one fantastic prize per person. So please sit on your hands or type the answer into a window. We have a lot of new people. And the first person with the correct spelling and all that good stuff is the winner of a fabulous prize. What's today's fabulous prize?
The prize today is going to be the gyro.
You get a gyro. Wait, what if you're not in the U.S.?
What? If you're not in the U.S., I'll come up with something else.
Okay, you'll get an IR distance sensor.
Yeah. That's fine. Okay. Here's the trivia question.
You do not win a $12,000 VNA.
Yeah, you don't get that. D is for diode. Who is best known for making the diode?
Discovering the diode.
Can I see the book? We have the coloring book here, so I get to check.
It was discovered?
Yeah, best known for inventing the diode. It originally called the kinotron.
I like that. The kinotron.
It's not Alexander Diode. It's not Tchotchke.
Did you discover a diode or did you invent a diode? I mean, diodes exist in nature, so it's tough to say whether it's discovered or invented.
Identified the properties. and the use.
Way to manufacture it.
Yeah, what is it? We got
It's
this
maybe
coloring
to
book
figure out
here.
how to
Way to
manufacture.
reliably
Right.
manufacture it.
I remember when I was at the lab.
It's not Trotsky, guys.
Noah Votter was a student
Not
of the lab,
MOSFET,
and he was
he's a
trying
cat.
to make
I have
a
MOSFET on my lab.
synthesizer using only like naturally found stuff. So
It's
we
not
actually
cat
make
whisker.
Oh, cool.
diodes by like setting fire to like to oxidize metal to create a diode.
And
Oh,
nice.
He was
question,
trying to
Bill.
build like a.
Then he burnt the lab down
He's
and
got.
then revoked
Can I
his
get a
rights.
hint about his facial hair?
Did you get good sounds?
I'm waiting.
I mean, you could probably look up Kinotron, right? Kinotron.
You could probably look up
Probably on
Kinotron.
Is what he
the
called
Wikipedia
it.
page for the diode, right?
People really need this coloring book.
Yeah,
it's-
They
Yeah,
need
yeah.
this coloring book badly.
I'm telling you, if you have this coloring book, the next 25 Ask the Engineer trivia questions will be very easy.
People keep
Yeah, a
saying-
lot of
people
5-year-olds
keep
are
saying
gonna
broad,
know.
but it's not. The person who's known for
I wonder if did you make a mistake?
I don't think
That's what
so.
they call this.
I guess I could have, but I don't think so. This is a good way to catch.
This is a good mistake catching.
Yeah.
Maybe multiple people invented it.
Okay, someone finally got it. John Fleming.
Did you download the PDF of the coloring book?
Here it is.
Yippee Jake.
Go,
Sir John
Beck.
Ambrose Fleming. Best known for inventing diode, originally called the Kinotron.
Hmm.
That's it. Congratulations. It was John Bayer.
John Bear.
John Baer.
Email support at Adafruit.
Support at Adafruit. And you get, if you're in the USA, you get the
The gyro.
Zara. Okay, we're a couple minutes late, but we're gonna. Oh, someone wants a discount code again. Do you know what discount code is, everybody?
It's K-Town
K-Town.
Graham.
Griff.
It's K-Town Griff. Use that code, 10% off.
I got it.
Oh.
Yeah.
He's right here.
Either him.
Yeah.
I know.
All right.
I think I've actually gone by that nickname. I used to
Griff?
work on 32nd Street, and I really love Korean food.
Oh, okay. Very nice. Okay.
K-Town. Oh, K-Town Griff. Right, for K-Town, which is Koreatown, and
Yeah.
oh man. Perfect.
My hotel.
Yeah.
My hotel is just beside K-Town,
Oh,
so
yeah.
Nice.
That's true.
I thought it
Alright,
was nice
so
of
that's
them just to roll
Moscow
out the
the cat.
welcome mat for me just before I show up. Yeah.
Delicious food.
Hey, MOSFET.
Can you make MOSFET in here?
I have seen
Briefly.
distance. I've been considered by MOSFET.
And my cat would like scratch my eyes out.
So would MOSFET. but
Yeah.
I would be very concerned
Yeah.
about this, but he's so mellow and sweet.
He's a good cat. All right.
Play us out, MOSFET.
Okay, well, let's just do a quick round. Special thanks to George for doing a recording, John Engineer for stopping in, Becky for doing some behind-the-scenes stuff,
Becky.
Matt for joining Adafruit, exciting times, Kevin for
K-Town.
coming in, Lady Ada for doing stuff, MOSFET for being very tolerant
I'm very tall.
He's so long.
of being a long
You
cat.
can't tell because
We'll see a lot of you at the Open Hardware Summit very
You like
soon.
popping
We'll
my
be
hair
at
bald.
Maker Faire. We don't know if we're going to be doing Ask an Engineer next week. Things are a little crazy. We'll let everyone know on the site. Thank you, everyone who are supporting Adafruit. We're a fun open source hardware company. If you like that type of thing, buy a kit. Use the code.
the cat
K-Town.
likes it when I hit him like this.
And we'll see everyone soon. Here is your moment of Zener.
Diode. Invented by Mr. Fleming.
Yeah.
Ambrose.
Yeah, they said that there was a bunch of.